Hi, welcome to my YouTube channel. This is David, or Dave once again, as your host. And this video presentation will be another video clip, or video as such, where I'll be using the services of my homemade variac or auto transformer, where I'll be testing this motor right here on the right side of your screen. And this is basically a pump motor. So in essence, it's a synchronous motor or induction motor. Here you can see the allotted capacitor, and this is basically a pump motor that has been salvaged from a faulty or non-working Galanz dishwasher that I scrapped, I don't know, about 6 months ago, perhaps even already a year. The heating element on the previously mentioned malfunction, so instead of buying a new part or a used part, in order to make it still workable or functional, we decided to get a completely new dishwasher altogether. So some of the parts I managed to salvage, and this is one of them that is still usable and can be used for various other projects. As usual, I'm going to give you a brief rundown or description of the equipment that I'll be using for the purpose of this video presentation. Firstly, the most essential part is, of course, this homemade variac in this black enclosure or metallic case. It comes with the input AC power cable that will be attached into this power cord, and then the final AC voltage, variable AC voltage, will be generated through this white cable, of course, by turning the knob or improvised gear clockwise. And for voltage references will be this digital multimeter right here on the left side of your screen, VoltCraft VC404. I'll be securing everything into place into this coupling right here with my screwdriver, and this green alligator clip will be used for ground, and one part will be connected to this wire that is sticking out on this side. This is where the ground wire from the 3-strand cable is hooked into. And then I'll be using this black cable, which has special connectors that will be attached onto the couplings of the motor in order to establish the connection and apply voltage to it. And of course, this side of the wire or wires will be connected into these two sockets of the coupling. Now, before I go into the actual testing part of this video presentation, I still have one debt to pay off, and that is the introduction part of the first part of this video presentation, where I tell you a little bit about the device that I'm testing, therefore motor specifications, and give you a brief visual inspection of thereof. So let's start. So this is how the motor pretty much looks like. You have one label here with some information, and then this is the main label as such. This is, of course, the manufacturer, the model, and then of course the voltage interval on which this motor runs. This is the current draw, 370 milliamps or 85 watts. Well, it's actually an interval if you take into account this voltage. So it actually draws somewhere between 81 and almost 90 watts. And this is, of course, the rotation indication, how the rotor spins and how everything is wired, including the capacitor. And of course, here is the actual capacitor. Let's have a look. It's a 3 microfarad capacitor. Here I can mention that the original one was 2.5 microfarads. So this is a new capacitor, even better one. Here is, of course, how the connections are made, going into the inside of the motor. And this is the actual coupling. Maybe I can zoom out or focus. There we go. Now these two couplings or connectors will be the ones to which I will attach that part of the black cable in order to establish voltage flow. So the case itself, the plastic part, it doesn't have any discolorations, so it isn't like yellow or yellowish. It's still nice in white color. Also from the bottom, no dust or anything like it. So it's very well, almost like in mint condition, preserved. This is the coupling to which my green alligator clip would go to. This is a spot welded, I think, to the steel or iron core of the induction motor, so this is grounding. And of course this is some sort of metal connector that I also decided to leave on when I detached or unscrewed the motor from the dishwasher. Of course you can use it, or you can remove it, unscrew it by removing this, basically two Phillips screws, longer ones. And here you have, of course, the M4 bolt or nut. And the top side view, so even inside nothing is yellow or you would have anything dirty. It's been cleaned. So this motor, well, it's actually heavy for you to hold in one hand because it weighs almost 2 kilograms, a little lower than that, 1.73 kilograms to be precise. So how fast does the rotor or this part inside here spin? At about roughly 2700 revolutions per minute. And the overall length, if I also take into account this mechanism here, is about 17 centimeters, while the actual motor part, this would be this length, is around 11 centimeters. And then how wide this is, or the diameter, that would be roughly at around 9.5 centimeters. And the stop opening, if I take into account the inner diameter, it is around 2.9 centimeters, and of course if I include the outer plastic, it's about 3.5 centimeters. And this side opening, pretty much also the same in dimensions. The inner one is 2.5 centimeters and the outside being 3.1 centimeters. I can also here mention, for instance, this motor can be used not only as a sort of a original replacement part for the faulty one in your own Galanz dishwasher. I actually forgot to mention what was the model from which this motor was taken out, which dishwasher. It was a W60A1A41A model, to be precise. The motor can also be then used if you're a much more adventurous person and if you don't mind getting your hands dirty or playing around with electricity. The motor can be used to pump various liquids of specific density or viscosity. Of course, besides water, various types of water, something from a river or a stream. You can also use this motor to pump, let's say, various oils, cooking oil, waste oils in general, also heating oil. And then if you're brave, you can also use it to pump schnapps and similar liquids. You would then, of course, need the proper plastic tubings of the desired length in order to attach them to this, to these two hole ports. And then, of course, in order to seal everything into place to prevent leakage or pressure dropping, you would need those metallic strips in order to tighten the seals, if you want to call it. A power or input power cable would also be then necessary to connect or power up the actual motor itself, so something like this one. And then a good thing would also be then actually a switch, something like this. So this is a 250 volt AC switch. I don't know how many amps, but I think it can definitely handle 2 or at least 1 amp, so something like this. You make the necessary connections and you have a homemade pump. Of course, you would, through this metallic piece here, install the motor on a wooden floorboard or similar in order to prevent it from going anywhere and to make it safe. And you can all have this motor for such purposes. Now we're going to move into the actual testing part of this video presentation. So I'm going to connect the multimeter and of course all of these wires to the motor into this coupling, and when everything will be set up, we'll start turning this knob and then visually inspecting and also in audibility detecting at which voltage the motor starts to spin, how loud it is, and so on. So I'll pause the camera and assemble everything, and then we'll start from there. Now for the actual testing part of this video presentation. As you can see, the Variac has been plugged in or powered on via this black input power cable, the primary one, and it's been connected into this AC power cord, and then through this white secondary cable the AC voltage will be generated, powering up this motor via turning this knob. So of course, for voltage references, the multimeter has also been set in the correct measuring range, and its assorted test probe leads have been inserted into this coupling into the holes, as you can see. And then of course, finally, the cable, the 2-strand cable, has also been connected into the same holes as the test probe leads are inserted, and then through these 2 special connectors it has been connected to this socket in which the other side of the couplings of the motor are located. And of course, finally, the ground wire via this cable has also been connected to this small latch or leg on the metal case of the induction motor. I'll probably just zoom in a little bit on this part and probably here and here so that you'll see that everything is connected as it should be. Then we'll start turning this gear or improvised knob clockwise to see when this motor starts to turn. Now this is a bit up close on this side of the wiring, how everything looks like. I'll zoom in on this angle in a couple of seconds so you can see it much more closely. Now this is again much more zoomed in. So as you can see, of course, the test multimeter probe leads are in, this coupling, and then the middle black extension cable is also connected into each individual slot. And here this wire is of course in the ground, connected by this green alligator clip. Now I'm going to show you the motor side. So again, on this side, the other end of the green alligator clip is connected to the small latch or coupling, which is then spot welded onto the entire iron or steel core of the induction motor. And this socket here, which houses 2 couplings, have also been connected via these 2 connectors on this end of this intermediate black cable. So if I was to look at this in terms of color coding, the blue wire on the white cable through the black intermediate cable is connected to the blue wire on the motor, and then the brown wire is connected to this black wire on the actual motor. It doesn't really matter because this is AC, so polarity isn't the question here, but nevertheless. So of course, and the multimeter has been set in the corrected measuring range. Now we just need to start turning the knob. I'll probably reposition the motor so you'll be able to have a much better look inside, so you'll be able to see when it starts to spin. I mean the rotor part and the connected mechanism of the pumping part. Now I'm going to start with the usual 50 volt AC increment to see whether we have any movement. I have positioned the motor so that you have a look inside, so you can see when perhaps this rotational blade part might start to spin for visual indication. So 50 volts and nothing. Let's see if we can give it some assistance. You can hear that high voltage AC hum. So nothing at 50 volts, but because I've tested this, I know it will start to spin at 80 volts when I give it a little bit of a push. There you go. There we go. So the motor works at about 80 volts AC when we apply some assistance to it. Now we're going to see when the motor actually starts without giving it a little push. So I'm going to move down the voltage again to 1 volt, and then we'll actually see when it starts to spin. So we're past 100 volts AC, and it works at around 107 or 108 volts AC. And interestingly enough, here you can feel the breeze. So this is definitely the part where the water or the liquid would go in, and this is where it would be blown out or pumped through, because I can feel it working like a fan. So let's go slowly. I'm going to have to hold it. Let's go slowly up 50 volts. So the audibility of the motor actually doesn't increase with that last 50 volt AC increment. Let's see if it changes when I go to 200. Nothing really. So if I was to measure by hand or by feeling how air is blown out, I would say that the airflow doesn't increase very much with voltage increase. So let's go to the lowest nominal voltage, 220 volts. So still the motor works, and let's go to 240. So perfect one. Nah, I can't leave it freestanding because the vibrations. So this works very nicely. Maybe I can try to take it in my hand. Gotta be careful I don't get electrocuted. This is dangerous voltage. So as you can see and hear, the motor works just perfectly. You can grab it here by the capacitor. So that's it. I have basically come towards the end of this entire video presentation. I have concluded the second part of this video review, if you want to call it, on this motor. In the beginning I gave you a specification overview and visual inspection on the motor, and now I've actually done the testing of the ROV. The motor works, performs perfectly. I would say it is actually quiet, in comparison to like the fans that I was testing. I would say it's much more quieter, but that is just my estimation. So if this is something you might find useful for your either used as a replacement part or as a project in your some sort of a homemade water, oil, schnapps pump, etc., this is the motor that you definitely should have. As usual, the comment section is open, so comment, ask, criticize, like, even subscribe, and if you want to share it, you can do this as well. This is David telling you goodbye and have a nice day, and we'll see you in the next video where I'll be probably testing another type of a pump motor, but much larger one. So goodbye.